When installing a single-string battery disconnect on a 24-volt DC 1200 amp disconnect, several requirements must be met to ensure safety and compliance. Firstly, conductor sizing is crucial. Use conductors sized according to National Electrical Code Section 690.8, which covers Class 2, or Section 690.9, which covers Class 3 requirements. For a 1200 amp disconnect, a minimum of 2 3/0 American wire gauge conductors is recommended. This ensures the conductors can handle the current without overheating or causing a fire hazard. Secondly, insulation type is important. Use conductors with appropriate insulation for the voltage. Examples include THHN, RHH, and XHHW. These insulation types are designed to withstand the voltage and environmental conditions typically encountered in DC systems. Ensure the insulation is rated for at least the maximum voltage of the system to prevent breakdowns and short circuits. Thirdly, circuit protection is essential. Install an appropriate DC circuit breaker or fuse upstream of the disconnect to protect the conductors and battery. Size the circuit breaker or fuse to the maximum continuous current rating of the system. This protects the system from overcurrent situations, preventing damage to the conductors, battery, and other components. The circuit breaker or fuse should be readily accessible for maintenance and replacement. Fourthly, the enclosure is a critical component. Use a National Electrical Manufacturers Association 3R or 4X rated enclosure to protect the disconnect from environmental conditions. An EMA3R enclosure provides protection against rain, sleet, and snow, while an EMA4X enclosure offers additional protection against corrosion and submersion. The enclosure should be properly grounded to prevent electrical shock hazards. Fifthly, terminations must be secure and reliable. Use proper crimping tools and connectors to ensure secure terminations. Torque all connections according to the manufacturer's specifications. Loose or poorly made terminations can cause overheating, voltage drops, and even fires. Regularly inspect terminations for signs of corrosion or looseness and tighten or replace as needed. Unlike alternating current boxes, there are no specific spacing requirements for direct current disconnect enclosures. However, it is recommended to maintain adequate clearance for maintenance and access. Allow enough space around the enclosure for safe operation and maintenance. This ensures that technicians can easily access the disconnect for inspections, repairs, and replacements. Ensure there is no obstruction to the disconnect handle or other operating mechanisms. This allows for quick and easy operation of the disconnect in emergency situations. Provide sufficient ventilation to prevent overheating. This is particularly important in enclosed spaces where heat can build up and damage the disconnect. Additional considerations include following all manufacturer's instructions for the specific disconnect being installed. Each disconnect may have unique requirements or recommendations that must be followed to ensure proper operation and safety. Label the enclosure clearly to indicate the purpose and voltage of the system. This helps prevent accidental disconnection or misoperation. Lockout and tagout procedures should be established for maintenance and service. This ensures that the disconnect is de-energized and cannot be accidentally re-energized while work is being performed. Proper grounding is also essential for safety. Ground the enclosure and all metallic components of the disconnect to provide a path for fault currents. Use appropriate grounding conductors and connectors, and ensure that the grounding system is properly bonded to the building's grounding electrode system. Regular inspections and maintenance are crucial for ensuring the continued safe and reliable operation of the disconnect. Inspect the disconnect for signs of damage, corrosion, or wear, and replace any damaged or worn components. Test the disconnect periodically to ensure that it operates properly and disconnects the circuit when required. Keep the enclosure clean and free of debris to prevent overheating and corrosion. By following these requirements and recommendations, you can ensure that the single-string battery disconnect on a 24-volt DC 1200 amp system is installed safely and reliably. This will protect the system from overcurrents, short circuits, and other electrical hazards, and ensure the continued safe operation of the battery system. Remember to consult the National Electrical Code and other applicable standards for specific requirements and recommendations. Always follow the manufacturer's instructions for the disconnect and other components. When working with electrical systems, always wear appropriate personal protective equipment such as gloves and safety glasses. Work in a well-lit and ventilated area. If you are not comfortable working with electrical systems, consult a qualified electrician. Electrical work can be dangerous and should only be performed by qualified personnel. By taking these precautions, you can minimize the risk of electrical shock and other hazards. In summary, installing a single-string battery disconnect on a 24-volt DC 1200 amp system requires careful attention to conductor sizing, insulation type, circuit protection, enclosure selection, termination methods, and spacing considerations. Following the National Electrical Code, manufacturer's instructions, and other applicable standards is essential for ensuring a safe and reliable installation. Regular inspections and maintenance are also crucial for maintaining the continued safe operation of the system. Always prioritize safety when working with electrical systems, and consult a qualified electrician if you have any questions or concerns.